I'm Kate Bachmann, editor with MetalForming magazine. We are here at the MetalForming Hot Stamping Experience, and joining us is Thomas Ausmann. He's with Telsa, the Global Advanced Engineering Department. How are you doing today?
Good, thank you. It was a great show, thanks.
Very exciting day for you.
Definitely. Yeah, it's an official launch date for the Cybertruck, so we're quite excited at the plant in Austin, Texas. A lot of work. The team's been quite busy the last couple of years.
And you as well.
Yeah, myself too.
As I understand. Very exciting. So in terms of hot stamping and in terms of your being with Telsa, how did you happen to start working at Telsa? And tell us a little bit about what you're doing there.
Yeah, my background is really tool and die making for many years. I later went to school for engineering and then program management and business after that as well. So I worked internationally quite a bit for a lot of large companies. Hot stamping over the last 20-25 years is a field that I kind of got specialized in. Still working with traditional stamping, roll forming, all metal type of technologies and assemblies and so on for the car market. But definitely hot stamping is a growing market, as we have seen through the conference here in the last 2 days, and it's really taken off in percentage of vehicles, content, EVs, really pushing the steel makers to come out with products that can be used. They're lighter, safer, and more manufacturable. So in joining Telsa, a kind of approach or new system approach that other OEMs don't really utilize or haven't really deep dived into it as much as Telsa does with new technologies they want to get into.
Well, and I know that when Telsa decided to develop the gigacasting, a lot of stampers clutched their pearls, so to speak, a little worried about losing, some of the stamping business. And as I understand it, the casting could replace something like 70 stampings. And so now that Telsa has decided to look at hot stamping, that's a great relief among the stampers. So let's talk a little bit about that aspect of being able to stamp a very large piece that formerly had been a stamped assembly or a gigacasting.
Telsa, I would have to say, with the gigacasting really shook the market, made everybody kind of wonder what direction they should go in terms of assembly and making parts more easier to assemble with less parts. It definitely makes production somewhat easier. If the volumes are there, that of course helps. So that's a big aspect of it as well. But a lot of suppliers, as we had seen through the conference here, a lot of suppliers are taking on the challenge as well for some new direction with hot stamping. So that's great to see as well.
Very nice. And so let's talk just a little bit, and you did allude to it. What are some of the advantages of hot stamping versus cold stamping?
Yeah, definitely started in Sweden a few decades ago. It's really taken off the last 20 years. They saw the advantages of not only safety, but having a part that's a lot lighter in the vehicle too. So for the mass of the vehicle, then fuel consumption, it used to be the big thing for fuel consumption. Now it's how long can the battery last, and that's a big player. That's one of the advantages. For forming, it has advantages. You're heating the material up to 920, 930, 40, 950 degrees, and it's just easier to form, but in the quenching process, there's also some challenges as well.
What are some of those challenges?
The struggles are definitely the galling on the tooling. It's you're quenching in such a rapid time, so that's very rough on the actual tooling. The automation's come a long way, but still to deal with the part that's 900, it's looks like an orange towel really when you put the blank into the press, which forms the part. But there's some of the challenges, and simulations have come a long way, so those challenges are getting less and less, like they've been tackled over the years, and there's a lot of R&D going on and has been for quite a while now.
Well, in your presentation here at the hot stamping experience, you did kind of outline some of the advances that are going on in hot stamping and some of the improvements. Can you touch on some of those?
Yeah, definitely. Well, first of all, the other industries are quite interested in the technology. There's advantages for mass transportation, railway, for the trucking industry, aerospace as well, even bicycles and that. They're really looking at hot stamping as well. But the more companies and industries get into hot stamping, the less investment it would take, and it becomes more of a normal commodity, where in the past it was a specialized commodity and very expensive. So the prices are stable, but hopefully we'll see in the future that the prices will come down for investment and for the for the OEMs, also for the piece price that they pay for the product.
So if I'm understanding you correctly, you're saying that as hot stamping as a process improves and becomes more affordable, so too will the vehicles, the electric vehicles?
That's the goal. That's the goal. There's many challenges putting any type of vehicle on the road, and pricing's a tough one to tackle. You're dealing with different economies around the world, so they're at times fighting each other. The steel market, then we had COVID. We just got over COVID. Unfortunately, in Europe, there's been a war in Europe as well. There's so many unexpected things that come up that affect pricing, and shipping around the world. It's still an international market for automotive, so that's a big part of it as well.
So in terms of some of the advances, one of the things I think you referenced was materials. What advances are you seeing in materials?
There's new products that are based off of hot stamping. So you have hot aluminum stamping now. That's quite common. So a lot of OEMs are introducing that, and it's been around for a little bit, but it's gaining popularity now with EVs. There's other advances as well with different layered or rolled materials that we use, different thicknesses, so that you don't always have to have a thick, heavy part in the vehicle, and you can optimize with simulation and FEA analysis what is the most economical part to use. One
of the things you mentioned was aluminum. So originally, as I understand it, hot stamping was basically boron steel, where the material itself actually changed its composition. Is that true in aluminum as well?
Yeah, aluminum is similar. It's not, you don't have to heat it up as much, and then it has a secondary annealing process. So it's a longer type of process, but it has its advantages and disadvantages. So depending for the designer of the vehicle, he has another tool in his toolbox that he could potentially use as a product as well.
And then originally the materials were uncoated, and now are they primarily coated?
Mostly at 95% they are coated, yeah, so it makes it a lot easier. That has some other challenges as well for that. So the controlled atmospheres in the furnaces are very important, and also just the process as well, that you don't disrupt the coating. As I mentioned earlier, with the galling of the tooling, so the tooling has to be modified at times to ensure that the coating is still is there.
Is that the primary way that you manage the coatings, or are there other ways as well?
No, I wouldn't say primary way. There's just some process windows that have to be set with the process that you put into your manufacturing to ensure that you're still safe within the zones of what you want to produce the part.
Are there any sort of rules of thumb related to that process window?
There are some, yeah. There's definitely a larger window you can go in, but as companies need to be competitive, they want to be on. They want to close the window and make it more, faster cycle times, faster processing times. So the problem is if you speed something up too quick in hot stamping, you can have other issues as well. And the integrity of the part is very important, especially for the crash effect parts that go into the vehicle.
What about indirect versus direct process?
It's just the difference of going in with blanks, where you go directly into the furnace and then you process the blanks from there. There's some processes in the past, it was a little bit more common and a secondary process, but to form the part cold, and then once it's formed, go through the furnace and then do your final forming and quenching, where you have the martensitic structure to go into austenite and get it to the right hardness of what you want to achieve for that product.
So I heard during the conference, it sounds as though manufacturers are developing some kind of hybrid approaches, where they're stamping the part, to its martensitic state, and then doing some additional forming, or, a couple of different approaches to the quenching.
Yeah.
Do you think that these will be continued to develop and perfect?
Yeah, there's a lot of OEMs that actually use that currently. So it's you can call it zoned hot stamping, where there's certain zones that are purposely not hardened, so that you want a softer area that helps the crash performance of the vehicle. So you don't want it fully hard or brittle in some areas. So some areas and different approaches. You can do it in the tooling. A lot of the furnace manufacturers, they actually have a separate furnace that it goes into a process where they address the area that they adjust the temperature of that area, so you don't have that hardness. There's a transition zone from there to the hardness, but a lot of the OEMs are actually utilizing that, so it's become quite popular. It's a little bit slower in the process, but it's still relatively not, I wouldn't say new, it's been around for 20 years, but it's getting more popular now.
And you just touched on furnaces. So are there advances in furnaces and the rollers?
Yeah, the biggest difference is you have either a chamber type of furnace, where some people call it the pizza oven, but there's different layers that you can actually open each door separately, or you have a longer roller hearth furnace that enables the product to slowly get up to a speed and continuously just go through the furnace. Some OEMs prefer one over the other. The roller hearth furnace are more popular. That's more than 80–85% of the market that uses roller hearth furnaces over the chamber ovens.
Have you seen any changes in terms of the rollers themselves, their composition, or?
Yeah, the rollers, they've come a long way too. So there's one of the furnace companies, Bentler, in Europe. They have a Bentler furnace that's sold quite a bit around the world, that they have a cactus design that they use. So this cactus design, it's unique from, if you look at the side cut of the roller, the ceramic roller, it's has less contact, so you have less of the coating that's on the material, and as it goes through the furnace, that contaminates the rolls, where you have less maintenance, less cleaning, overall less cost and downtime.
So it sounds as though the goal really is just reducing the maintenance and therefore the cost, reducing the cycle time, reducing the cost of the process to, transfer those cost efficiencies on into the product. Are there any changes in terms of the dies?
The dies, the big difference obviously for cold stamping is you don't have any cooling, quenching mechanism. Hot stamping you do. First, when hot stamping came out, was the dies, the sections, forming sections were actually were cavity milled out, where now they're more gun drilled, so they have channels that go through the tooling. Sometimes if there's a patchwork, like an extra thick material in an area that you need the extra support on the part, then that area might still have additional cooling, like a cavity cooling in that area to absorb a lot more of the heat and to balance it and to increase the efficiency, so shorter cycle time. But definitely the tools have come a long way, and as mentioned earlier, the simulation has definitely helped in that area.
Let's talk about the simulations. As I recall, a few years ago, there was not the ability to simulate thermal changes. And can you talk about that a little bit?
Going back even 20 years ago, we used 3 companies. We used PAMstamp, we used AutoForm, and we used Dynaform, and we weren't really sure, and we had to make our own cards for hot stamping, so we'd take coils of material, we'd do testing against the grain, with the grain, 45 degrees to the grain. Some OEMs didn't want, they actually insisted that they show you which is the grain direction. In hot stamping, it actually becomes uniform after, so it's, but that's just some of the historical ways that we developed it over the years. And at that time too, then comparing the 3 simulations from the 3 different companies and approaches they had to kind of get best practices, go back to the actual tool, if it's the prototype tool or the production tool, and feed that back to the simulation and really fine-tune that, and it's really come a long way. AutoForm, they've really taken the lead in simulations, where they work directly with some of the universities. They work directly with the larger tooling companies worldwide for hot stamping specifically, and even for the tier 1s and some of the OEMs in hot stamping. So that's, they look at friction analysis, the heating, the cooling, and all that put together is a pretty complex recipe that they've come up with.
Yeah, sounds like there's really, really a lot going on in simulation.
Definitely, yeah.
And what does that do for you? Having, being able to work things out in simulation, what does that do for you? It's kind of a rhetorical question, but
Yeah. It saves a lot of time up front, because up front, in the past, it would be a designer making it, and if they're not maybe as confident with the manufacturability, especially in the steel making, they have the support from the simulation, and usually if you have some of the feedback from the tooling companies or the production process people that give them feedback as well, so they can actually make a design that's actually feasible to make. So it's cut a lot of time out, and also when you get into some of the first hits, it's amazing how close they are now compared to the past.
Excellent. Then one other thing that you touched on yesterday was the presses themselves, that there have been some advances in the presses, and what do you see for the future?
The presses, yeah, they've as well, like ultimately the press goes up and down, but
Yeah.
hot stamping, it's hydraulic press that's utilized. So the servo presses have really shown a lot of advantages in hot stamping to control the speeds, the press curves. With hot stamping as well, that you need to have the press on bottom as well, and then also ensure that the part is really on bottom, that you can actually hold it and quench it, and that's where the magic of the press actually is. And then for closing, some products actually need a very rapid closing, so you can adjust your speeds for the closing, and then for part exit as well, you want to try to increase the even the RAM going up as well, to ensure that the part comes out as quickly as possible.
So using a servo press rather than a hydraulic press is relatively new, isn't it?
Yeah, they've combined the
Okay.
two. It's just the technology they use and how they manipulate where the oils of the hydraulic is in the press, and it's a lot of Industry 4.0 that they've added as well. So a lot of controls of the press and the product as they're making it for each part. So it has its own recipe for each part.
Wonderful. And so it sounds like we've hit on most of the advances, and I'm sure that the process is being perfected. And then there was one last thing that you touched on, was the post-processing.
Yeah.
What do you see for the future of post-processing, or what are the latest advances?
The OEMs have really come on board as well. So some OEMs, they go directly from the hot stamping into direct feed into the laser, and then direct feed into the sub-assemblies, and in some cases even direct feed into the final assembly, so the general assembly. So that reduces floor space, it reduces amount of inventory that's required. So that's a big thing. But in general, the laser companies over the years have come a long way with hot stamping. In the past, post-processing sometimes included hard cutting, where the edges would get trimmed away, but that was very difficult for the presses. It was a very expensive process, and also the tooling wear was very high. So the preferred method is really with the laser. That's 99% of it. There's still some minor parts that are areas that are trimmed, either punched, if it's a datum hole that's punched, or if it's an edge that's trimmed for some reason.
Very good. Well, we talked a lot about this process in the future and where it's going in the future. So back to the future, the Cybertruck has been referenced as a vehicle that looks very much like the vehicle that was shown in the movie Back to the Future. Yeah. So a lot of fun there. So a lot of excitement surrounding the Cybertruck and the launch today, and the fact that the body is made of stainless steel was very surprising and very exciting. And I know that we had talked about the body aspect of it is not something that you're closely involved in manufacturing, but I'm sure there will be more announcements about that.
Oh, definitely, yeah, definitely. It's as you mentioned, the DeLorean originally was Back to the Future. Was a car that a lot of people recognize. It's a stainless steel body. It's an interesting car, and it's some of the the designs almost look similar to some of what's out there now with what's being launched.
Very similar. Well, if we start, feeding it garbage to fuel it, then we'll know that we've made full circle. Yeah. So we talked a lot about the future, but I'd like to end up here, finally just talking a little bit about your past, your background. You have a very, very interesting background, and both geographically and experience-wise. So you believe you were born in Germany?
Actually born in Canada. My parents migrated to Canada in the early 60s. I was born in Canada, went to school for a year when I was in grade school, back to Canada, then worked for a large company, Magna International at the time. My father had a tool and die company. We sold it to Magna in the mid-80s, and I joined Magna in 1988, was 17 years with them internationally. It was a very small company at the time and it grew. So I went through those growing pains internationally, a lot of launches of new facilities and product launches. And yeah, definitely a lot of international experience for sure from that side. Automotive really gets you around.
It really gets you around. So you were just recently in Germany. You were there for quite a little bit of time, I believe.
Yeah, the last 2 years, Tesla, we do have a plant in Berlin, and the plant came up into production last year, in the spring last year, and for a lot of the OEMs. As I mentioned, automotive is very international, and Germany and Europe has a lot of advanced technologies that they use for equipment, tooling, and some of the engineering as well.
Did you get a chance to tour any plants there that were performing hot stamping? Yeah, there's quite a few internationally over the last years, definitely, that have had the privilege to visit. And so you've been kind of globe-trotting around between Germany, Canada, and Austin, Texas, a third country, really, of its own, yeah. Almost. And so what is that like culturally to be experiencing so many different, kind of cultures?
Well, once you get over the jet lag, then it's the cultures, you adapt to it. As a Canadian, and with German parents, I was always growing up between the two worlds, and the U.S. is very similar to Canada. We have every state, every province is slightly different, but it's always good to see the nice people in Texas, and launching the vehicle there and spending a lot of time this year there. Getting that off the ground has been a lot of work, but like we said, today's the launch date. So.
Very, very exciting. So just wrapping up, what would you say could be the most surprising thing about you that people don't know about you?
Well, there's a few probably, I'm sure. I used to be quite involved in sports. Hockey was my main thing. So I had the pleasure of playing in Germany, pleasure of playing in Canada and the U.S. When I was younger. But prior to COVID, actually, I was still playing. But other than that, I do enjoy gardening. 8 years ago, purchased a large farm in outside of Toronto. So it's a small, well, I wouldn't say large farm, it's small. For me, it's a large farm. But it's a small organic farm it's more of a hobby farm. And that's my future retirement area.
Very nice.
I don't think there'll be any hot stamping there, though.
Probably not. And then I think you may have dabbled in cooking.
Yeah, for the beginning, I was in high school in Canada. I worked part-time at 15 already at a golf course, and worked. My friends all got a job at the pro shop. They had nothing available, so I ended up in the kitchen. The first year was doing dishes. The second year, short order cook, and I kept working my way up. And last year in high school actually was interesting. They had a co-op program where I had the privilege to work at one of Canada's top French restaurants as a co-op student. So I did that for where you work one semester, 4 days. Every Friday you go to school, and that's an area I enjoyed. But with my father's tool and die company, kind of got pulled back into that, and that's kind of been, I guess, my grandparents as well. They're in automotive, both sides. Volkswagen originally from Wolfsburg, Germany, and you can say third generation tool and die maker. So it's more in my blood. Well,
you have a very rich background, and I'm sure a wonderful future ahead of you. Thank you so much for taking the time to talk with us.
I appreciate it. Thank you.
Really appreciate it. So Thomas Ausmann again, with Global Advanced Engineering for Tesla.